Thank you very much for coming. Thanks to George and Dennis for the previous presentations. I'm going to go a little bit deeper into what Dennis just introduced to you, really. We're going to look at LLMs for self-hosting, very opinionated but also quite simplistic view. My name is Ben. I am the founder and lead engineer at a company called Temrel. And what we do is we help companies implement AI solutions, notably LLMs. I've worked at a few big companies across my career, doing various roles. Been in DevOps for about 4 years now. And although I'm English, as you can probably hear in my voice, I actually live in Paris. And I tend to split my time between there and here. Now, what's an LLM, you're probably asking? LLM stands for Large Language Model, and it's essentially what ChatGPT is. You've probably heard of that. It's essentially a very, very big record of the way words relate to each other. Okay. It's done through training. Those relationships between each word are kind of quantized by looking at literally millions and millions and millions of pages of text. Okay. And so once you've done that, once you've trained your model, you can actually ask it a question just like you were chatting to a human being, right? So you say, tell me a story. That's called a prompt, right? Keyword. And the model generates a response based on your request. Okay. That's called inference. That's the act of inference, right? And essentially, really, what it is you've got an app or command line. You have a model which is running somewhere, and you have some sort of API into it, basically. And that's really all it is. The easiest way to have an LLM, okay, to have AI, as you might know it, is just to use ChatGPT, right? Or something else that's presented via an API. You just log on to a website, type your query, and away you go. And that's fine, but it's not private. Now, these companies that offer these APIs, paid or otherwise, promise that they're not going to actually use the data you send them. But not a lot of people would generally believe that that's true forever. The reason why we would have privacy requirements is, imagine if you were writing some software and you were writing some code that was really kind of important, but also very cutting edge, gave you a competitive advantage. You want to use an LLM to help you write that code, right? But you don't want to send it to ChatGPT because then ChatGPT will know about it. It's also not fine-tuned. So large language models are trained on this huge mountain of text, okay? But they might not be trained on your text. Imagine you're a law firm, for example, and you have millions of documents internally. All those documents are really sensitive. You don't want those out in the public domain. But you do want your AI to know about them, right? You want AI to be able to respond to you based on your stuff. So that's what fine-tuning is. Obviously, if you're using a publicly available one, you won't be fine-tuned to your material. It won't be so personalized. And then lastly, as you might have seen if you've been using ChatGPT lately, it's not connected to current data. ChatGPT finishes in November 2021, I think, if I remember correctly. So anything that's happened after that, ChatGPT doesn't know about it, and it'll just tell you, I don't know, I'm sorry. So these are the three things, really, you want to get the most out of AI if you're a company, if you want to use that AI for a competitive advantage, okay? So the only way to do that is to roll your own LLM, okay? You need to have your own infrastructure, your own kind of application using LLMs. Quick aside, you see on the left there, conventional wisdom will have it so that AI is actually a subset of machine learning. LLMs are a subset of AI. Okay. At Temrel, we don't believe that. We think it's the other way around. Okay. Machine learning is just a subset of AI, in fact. We think it's because within the next 3 or 4 years, you'll find that AI is doing machine learning and not the other way around. Anyway. So there are 3 modes of use. As I mentioned, you can have what we call thin client, so just a web browser. You can create that web browser, or you can just use one that already exists. Okay. Then you have what we call roll your own. So you're taking a model that already exists and basically running it on your own servers. And then if you're really rich, you can build your own. Okay, so you can build your own large language model from scratch, which is phenomenally expensive. but it means you have complete control over it. Okay, I'm not going to go through all these in detail, but these are basically the design choices that we're thinking about when we're looking at this. Right, you need to consider these, not an exclusive list, but you need to consider these when you're looking at whether or not you need to roll your own or not. This is a slightly more business-like view of what we've got. So on the far left, you've got the no-code version. So that is just having ChatGPT tapping away on the internet. Then we go into slightly more advanced techniques about prompting. So instead of just asking it a question, you can give it, say, 5 examples of what you want and then ask it a question. Okay, that's called few-shot prompting. Then you can do retrieval. Retrieval is where you get up-to-date information. So you can say, can you explain this to me? By the way, here is a website that has some information that you might want. That's the retrieval element. And as we go up, we go all the way to the top. And if you've got $100 million and you've got some of the best data scientists and MLOps people in the world, you can train your own model from scratch. Generally, most companies would be in that green section just to the right of the public-private data line. Right? So, one thing to note about LLMs. Historically, when we had apps, you could have cloud-native apps. So apps that didn't start out live, maybe on the cloud. They were written and hosted in your server room or on-premise. Eventually, you migrated them through the help of some DevOps people, and now they exist on cloud. We can say they're cloud-native, but they can also still exist on-premise. LLMs require so much compute that that's no longer an option. It's cloud only, unless you're super rich and you can, as Meta, you can have your own data centers all around the world. But I mean, there can't be more than about 20 or 30 companies that really got the tech and the money for that. So we're not cloud native anymore, we're cloud only. It's definitely important to remember that. This is where the cloud only element comes in. We need to use GPUs. Everyone knows what a GPU is? Started out as things that were produced to make 3D gaming slightly more accessible to people because it can do lots of really, really fast compute in parallel. And then people realized that they can actually use GPUs for all kinds of other stuff that don't involve graphics at all. So it's almost a bit of a misnomer to have GPU up there, but that's what we're calling them. And these bad boys can do lots and lots of things really, really fast, really quickly. And they are the only way of processing large language models. Okay. If you look here, Llama 2 70B, which is Meta, Facebook's flagship model that they produced, that takes 140 gig of VRAM, right? Simultaneously, the best chip available on the market, the best GPU chip, is only 80 gig, so you're going to need at least 2 to run that. Okay. There are smaller models, of course. You don't necessarily have to have that. In fact, there is a smaller version of Llama that you can run, but you're still bound by this idea of having to have GPUs. Right? And unless you somehow have access to lots of GPUs and you have access to lots of money, it's going to be challenging for you to find them. It's quite interesting, actually, thinking about the geopolitical elements of this, because the supply chain of GPUs is pivoted between the US, Taiwan, and China. So definitely in the next 5 to 10 years, you might imagine there'll be some geopolitical tensions which might disturb the supply chain there. I read recently that Warren Buffett sold all of his stock in a Taiwanese GPU manufacturer. Make of that what you will. So yeah, we need to use GPUs, basically. There's no way around it. So big bucks time. If you wanted to buy one of those aforementioned A100s, it's going to cost you $10,000 retail if you can find one. Okay. Typically, the larger tech companies are making billion-dollar orders and scooping them all up before they even get onto the market. Okay. If you want to use a cloud service like Amazon, for example, the very smallest GPU server they've got is $35 a day. By contrast, this very smallest CPU server they've got is about 14 cents a day. So it's clearly very expensive. Don't make the mistake I made a little while ago of leaving one of these bad boys running on your own little test rig. You wake up a couple of days later and you've spent $100 on exactly nothing. But yeah, there is a significant cost. We're not going to be able to do this on the cheap, essentially. So we have 3 options with those GPUs. We can buy them if we can source them. We can roll them in the cloud, so we're still responsible for rolling the servers, but someone else's tech. Or we can use some of the emerging third-party providers like Beam, who basically put a wrap around it. They will manage, or they will abstract away your presence on AWS or Azure or whatever. Okay. These get progressively more expensive as they go down. All right. So when we're talking about using LLMs, we're talking about pipelines. Anyone that's been in MLOps for a while will understand the idea of data moving through pipelines. We've got three biggies, three essential ones for LLMs. Okay. We've got the fine-tuning one. So just as a reminder, fine-tuning is when you are taking your own material, your own secret source, and training that model on it so it knows about your secret source, knows who you are, it knows all of your clients' dirty little secrets, it knows all of your code. You might also see these referred to as training pipelines, basically. And that will give the model a much more tailored output, a much more value add for you. Then we've got the streaming pipeline, and this is where we are basically going out into the world to try and get fresh data and add it to our model. Okay. Training a model is a really, really long and expensive process. So we have to employ some kind of little techniques to try and make the model learn really quickly and cheaply what happened yesterday. Okay. So that's a streaming pipeline. We're streaming new information into the model. And then lastly, we've got the inference pipeline. So your model is somewhere, is running, and you need to get your responses and requests in and out of that model. Okay. And this is what it looks like, kind of very high-level overview. Okay. We start over on the left with the user prompt. Now, there are already in the market providers of tailor-made, kind of out-of-the-box front ends for large language models. Okay, like Radio and Streamlit. Okay. They produce what are called embeddings, which go in a vector DB. Okay. Without getting too much into the detail, vector DB enables us to store the relationships between things. In this case, in our LLM case, it's words. Okay. We can store the relationships between any words. So if you can imagine a very large graph, words that are related will be closer together. Words that are less related will be further apart. And that's in part how the model knows what to send back to you. If you say the cat sat on the mat, it's going to be right next to those other words in the vector database. Okay, and the way we put information in those databases is via something called embeddings. So we're streaming our new information into that embedding database too, and then we're using that to create what's called an enriched prompt. Okay, so we've taken the original question, we've added some extra information into it, and then we're also going to push back the conversation context. Now, I know if you've used ChatGPT, you'll know this. If you're writing in the same conversation, ChatGPT knows what you said before, right? It's not starting from fresh with each question you ask. So that's the conversation context. Take that enriched prompt, send it to the LLM. Okay. Previously, we've already fine-tuned the LLM, so the LLM knows everything about us and knows all of our innermost secrets and desires. Various different names, different flavors of model: Llama, Mistral, Falcon, etc. And then we get a response back, and again we present that back into our front end, okay, so the user can actually see what we've gotten back. All right. So this is a bit of a close-up on the fine-tuning pipeline. What we want to do here is we want to train the model on our data, right? So we're taking a chunked data set of input-output examples. So that is a chunked set of all of the questions and answers that we want to train the model on. Okay. We're pumping that into a GPU, into an algorithm which is running on a GPU. Okay. And there are different ways of training the model. What we don't want to do is train the model from scratch, because we'll end up back in that 100 million plus club. Okay. We want to train the model just a little bit so that it kind of resembles what we want, but we don't break the bank, and also it doesn't take ages. So we got a low-ranking adaptation, which is a way. I'm not going to go into too much detail because I'm too stupid to understand those details, but it's a way of training the model in a with a good trade-off between depth and efficiency. And then we have quantized low-rank adaptation too, which is a way of actually shrinking the model down. So, for example, at a very low level, you take a 16-bit number and you quantize that down to a 4-bit number. Do that a trillion times, and you've got a much smaller model. Okay, so then you can run it on a smaller GPT and spend less money. And then we put that into a model registry as an updated model, so we can use that to do the next generation of where we are, what we're doing. Our RAG pipeline. So RAG is retrieval augmented generation. Okay, so it's essentially a very fancy way of saying generating stuff from an LLM, but with up-to-date information. Okay, so we, again, something very similar. We take external data sources, we run it into a streaming library. Now, this is slightly cheaper, and that's probably something a bit more conventional. We don't need GPUs for this. It's probably one of the only elements that's not hideously expensive. But our objective of that is to create these embeddings that we put in the vector DB. Okay, we're not iterating across, millions and millions of different data points here. We're just simply embedding it. So it's a relatively trivial operation, but it does give us that live data element. And then lastly, we have the inference pipeline. So here we've got the user request going in. We've got an app which is running on a CPU. Okay, we've got our existing context, our enriched prompts. We pump that into the GPU, the LLM, which is on the GPU via an API. And then the whole thing just comes back. And that way we've got our chat. Okay, that's the chat element of GPT. And that's it. This is where we deliver the value. Okay, and this is where the most important stuff happens in LLMs. What you probably don't understand when you see what's happening in the marketplace at the moment in AI, you see lots and lots of companies saying, oh yeah, we've just added AI under the hood of our thing. They haven't added that. It's my assumption that they are just pumping your data into ChatGPT, okay, and spreading the cost on that. What will happen over the next 4 or 5 years is that we will end up with more and more companies doing exactly that, having their own AI under the hood, essentially. And with that, that's the end of my presentation. Hopefully you all understood. Yeah, thank you.